Hello to you and welcome to another Intertraffic webinar where today we're talking about connected road users needing connected road networks. Now, before I get into the introduction, let me just introduce myself. I'm Paul Hutton and I've got three experts to talk about this subject with you over the next hour and a half, but we very much want you involved as well. There are two ways you can do that. First of all, we'd like you to answer our survey questions we'll have throughout today's webinar, and also at the bottom of your screen here on Zoom, the new platform we're using for these webinars, you will see the Q&A function. That's where you can ask your questions and we'll pick out the best of them and I'll put those to our experts during the course of today's discussion. So smart mobility is expected to undergo spectacular changes within the next 2 decades with the introduction and widespread use of connected and autonomous vehicle technology. However, of course, the transition phase from human driving to self-driving will be gradual, requiring various interventions on the physical and digital road network to allow it to cope with mixed traffic. Connected road networks help secure and connect intelligent transport systems, allowing vehicles, roadways, travelers, and traffic management centers to all communicate with one another in real time. It allows for a smoother flow of traffic. It reduces congestion and improves road safety and paves the way for a foundation upon which connected and autonomous vehicles can communicate with their surrounding environment. So this webinar is all about coping with mixed traffic and using smart technology to connect infrastructure, vehicles and road users. Now, before we get on to our first guest, I want to know a little bit about you, please. So here is our first poll question that should pop up on your screen any second. There you go. Here is our first question. So do you work for a local authority or a national authority? Do you work for industry, a consultancy? Are you in research or maybe a trade association, or maybe you do something completely different within the transport sector? So do tell us what kind of organization you work for. It helps us understand what audience we have at today's webinar. So I'll give you a couple more seconds to put your answers in, and then we'll have a look at the results. And this is a great bit where I'm in England and the answers and the buttons are all being pressed in Amsterdam. So there is a slight wait there. So there you go. So over a third of our audience today are in industry, 20% in consultancy, and a whole 28% class themselves as other. So it'll be interesting to find out a bit more about the 28% who are other as we go through today's webinar. So I want to now move on to our first subject. And so we'll get to our first question, which is, what is, in your view, the leading innovation when it comes to connecting roads to vehicles and automated driving? So is it ADAS with autopilot? Is it in-car travel services, so your navigation and your info, cellular-based technology, connectivity like 5G, dedicated short-range communication systems, or advanced radar sensors, LiDAR, scanners, or cameras and so forth? So what do you think is the leading innovation when it comes to connecting roads to vehicles and automated driving? So I'll give you a second to read through and decide on your answers for that. As I look across at my screen to see, wait for your answers to come in. And then we will move on to our first guest, who will no doubt have some comments to make about this when you get to meet him. So there you go. The top answer is ADAS, which is interesting because, of course, that a lot of it is in the here and now. And a lot of people seem to think that autonomous driving is something that's still very futuristic, whereas actually we have an awful lot of connectivity and ADAS systems that exist for us already. Navigation, in-car travel services came in second. You saw the results there. So we'll have another survey in a moment, but we'll talk about that to our first guest. So let me set the scene for our first guest before we meet him. Connecting smart infrastructure future with connected and autonomous vehicles is the subject of our first discussion. So onboard sensors won't be enough to provide full autonomy for vehicles in the future. As cars become more autonomous, transport authorities must ensure roads are future ready, prepared, safe and smart. So by connecting smart infrastructure with connected and autonomous vehicles, traffic will be able to keep moving efficiently whilst keeping passengers and pedestrians safe. Data can be transmitted from roadside sensors to vehicles, providing critical ground truthing of autonomous vehicles and life-saving beyond the horizon detection for all cabs. Investing in smart infrastructure today enables a smooth transition to autonomy in the future. So let's welcome our first guest, who is Cheyenne Afshar, who is Clearway Project Engineer at Navtech Radar. So hello, Cheyenne. Thank you very much for joining us on this webinar today. We're going to do a kind of hybrid discussion here, because I know you've prepared a few slides, but I might catch you out with a few questions at the same time, because I want to ask some questions of you as we go through this. So, first of all, let's just set the scene. I've been lucky enough to visit your headquarters to the west of London. Navtech Radar is known for its long-range radar systems for automated incident detection and enforcement. It's placed on certain motorways here in the UK, and you've got installations all around the world. Can you explain how the technology works, please?
Yeah, of course. Hi, everyone. Hi, Paul. Thanks for this opportunity. It's great platform to share this kind of knowledge on. I'll just start by sharing my screen, if that's okay. Okay. So I trust you can see my screen. Okay, so yeah, radar, how does it really work? So on the right here, we have an image of one of our Navtech radars in the white here. So it's attached to this particular bracket, which is attached to the tunnel infrastructure, which you can see here. And this is actually for one of our projects that we're currently running in Norway, which is really cool. But anyways, so this is a radar attached to the tunnel infrastructure, and it can detect live traffic that is traveling in the road section below it for a specific detection range that we specify. Now the radar, it operates at 360 degrees and it operates at 4 hertz, which essentially means that it spins at about 4 times a second. And therefore it gives you strong resolution of the vehicle live traffic, or the live traffic that's traveling through the tunnel at that particular point in time. So to take a step back and discuss, I guess, how does it fundamentally, or the physics behind it, and a really basic overview of that. So I'm not going to go into too much technical detail on that. But on the left here, we can see we've got an image of a radar, and we send out a particular set of RF energy. That RF energy then will hit a target. So for instance, in this image here, it's this blue car, and then it will come back into the radar receiver. So we measure the time that it will come back, and we obviously know that what the speed of light, or the speed of electromagnetic energy is, which is about 3 × 10⁸ meters per second. And therefore, from that information, we can work out the range to the target. And in the instance of this particular radar installed in this tunnel, we get the vehicle live statistics, etc. So that's a brief overview of the physics of how it works. So I guess now I'll hopefully be able to show you in a video about how it actually works in our system software. So this video is from our Navtech Radar system software, and it will hopefully show the user interface in which we use to show these results, or to show the radar physics really at play. So hopefully you can see here, this is a map. It's actually a map of Oxford, the Oxford Ring Road, which is very close to where we're located. And you can hopefully see some of our radars, a series of our radars deployed here in the bottom left. And as we zoom in, you will see that we have got a virtual carriageway drawn on a real carriageway, in which one radar in the middle here is going to operate at and detect live traffic in. So this video will hopefully soon turn on our raw radar data, which will be the green raw radar data that the data basically sees. However way to explain it is sees raw. So without any processing or anything done to it, this is essentially what the radar sees as it's got the 360-degree views and it's traveling at about 4 hertz. So again, 4 times per second. So you can see that in this video right now. So as we zoom in a bit closer, you'll hopefully see the radar raw image showcasing the stronger reflections occurring from the stationary objects that we see. So this will lead to the stationary objects being the objects on the side of the road. So for instance, any signs or any kind of trees that form along the road, that will pick up that as a stronger kind of reflection. And if I continue playing the video here, you'll hopefully see some traffic moving along those virtual carriageways, and you'll hopefully see stronger reflections or stronger moving reflections coincide with that moving traffic as we go along. So that green image is basically, again, what we see from the radar without doing any processing to it. Next, what we do is we take an image of that radar raw data, and that image serves a key purpose of capturing all the stationary objects that we have around the radar. And that is because we're not interested in things like trees or signs that are in play. We don't want the radar system to detect that. And what we do is we capture a clutter floor, which you'll see in this yellow image here. If I continue playing this, we then subtract, or we take away from the green, the raw radar data minus our stationary image, which is the yellow, and you'll hopefully be left with some red process data. So this is what is effectively all the moving objects that we see. And this is what we find really important, because it shows us all the live vehicle traffic, and you can hopefully see that the stronger the return, or the stronger return of the radar signal, we tend to correlate that to a larger vehicle, larger reflections coming through. And then that's on top of this red process data, that's when we add the intelligent software associated to it, in which we say, okay, we see that this is coming up with a stronger return, therefore we're going to classify this as a heavier vehicle or a bigger vehicle. And that's when our classification comes in, our ability to measure speed, location, etc. And we apply then apply the vehicle tracking alongside or on top of the process data which we get. And yeah, to summarize, that really is we use this technology really to perform what Paul mentioned, which is automatic incident detection. And that's to detect stopped vehicles, detecting pedestrians, wrong way driving and debris, and also being able to monitor live traffic and classify and get all that information.
That's great stuff. And I've seen the stop vehicle detection used in anger. I've also seen how you've got the technology, the same technology could be used, for example, for enforcement of vehicles sort of driving too close to each other, or somebody who's sitting in the middle lane of a road when there's nothing on the inside lane, and so they're causing holdups. So that's all great, and I can understand exactly where all that works. But what I want to understand is how you take what you've got there and start to implement it with fully automated technology.
Yep. Let's go to the next screen. Okay. So that's a good question. So I think before we understand, how we can help this fully automated society or fully automated mobility, it's really important we understand the current challenges we actually face with implementing autonomous vehicles and moving towards what we see as what we call maybe full automation, where we have autonomous vehicles, lots of autonomous vehicles driving on the roads, said very simply. So, currently there is a little bit of concern growing that autonomous vehicles, itself, they just are not perceptive enough to handle that sufficient safety and autonomy that we're seeing, or what we want to happen. And these are things such as questions such as, how can a vehicle understand what is around it if the localized or if the onboard sensors on the vehicle, on the autonomous vehicle itself, cannot see them in the first place, if they're obstructed, for example, in these situations. And even if that perception is slightly altered, how can we trust that an AV can accurately classify obstructions or vehicles in its path? The second point being here is that we've got a very heavy reliance on events occurring close in to the autonomous vehicle. And therefore, we can kind of say that AVs or autonomous vehicles say they may struggle to see far enough over the horizon to handle any kind of dynamic highways changes that might occur over the horizon or at some distance away from the vehicle. And it's important to know, like in this transition period, as we're talking about going into a fully autonomous world, that not all vehicles will be autonomous in that transition period. And lastly, we have these different driving environments. So, infrastructure is going to be different, roads are going to be different. There's just going to be lots of, it's a very dynamic situation. So we need to really trust that these AV sensors are sufficient to adapt to those dynamic changes we see in the roads. So progress has slowed a little bit for autonomous vehicle implementation, and these can be attributed to some of these safety concerns I've raised. We can't just flick the switch and turn into an AV landscape. We need to obviously handle this transition into full autonomy as best we can and prepare for that transition very carefully. So in the case where there even is a little bit of risk of a compromised sensor or compromised local sensor, then we must really try to understand and ask ourselves what additional help may these sensors need during this transition period as we're looking to go into fully autonomous. So when we're asking that question, the way that our sensor as part of this smart infrastructure, or really as the way that smart infrastructure can help in this transition phase, is through, well, we've outlined as 3 ways. One of them being non-line of sight, so from 0 to 50 meters. So non-line of sight perception. So this is when we say that localized sensors become obstructed and can't see something that is close into itself. So what the smart infrastructure can do is give it essentially a different perception or a different viewpoint to what the localized sensors may be seeing, and therefore help or aid in the detection of things in the case where it is obstructed. Secondly, it's this around the corner coverage. So from about 50 to 100 meters away, let's say. And this is again, in the case where we're coming around a corner and the sensor is slightly obstructed for some reason. And this is again, the smart infrastructure can help in that process because it gives a different viewpoint and it gives a different type of perception to that. And lastly is this over the horizon kind of detection. So looking, again, as the name suggests, over the horizon up to 1 kilometer away. And this is incidents that occur over the horizon. You really give the autonomous vehicle or the vehicle that in question advanced warning of something that has occurred, and any kind of dynamic highways changes that will incur from that is extremely important.
Okay, so now, so how is we going to, you've explained how we're going to help the transition to fully automated mobility, but explain a bit more about the data for me, please, Cheyenne. Is this raw data that somebody's got to interpret, or is it immediately applicable and usable for road authorities? And how can the sensors contribute to robust traffic information for road users?
Yeah, so good question again. So we can obviously give both the raw data and what we call the track data. But I think for what's the most applicable for everyone is the track data, so the data that comes after the processing. This is obviously in line with the image I showed before with the radar and its detection zone underneath. So it will be in line with the track data from vehicles traveling in that detection zone of the radar. So in terms of the track data from the radar, this can be information such as the velocity of the vehicles traveling, places where we have queues, places where we have incidents, we have stopped vehicles, speed of the tracks, location of the tracks, and classification of the tracks. So for instance, identifying whether or not we have a large vehicle, a car, or maybe in some cases pedestrians. So what this information can give you, so what this track information and this detailed data can give you, is we can result in a few different things, a few different scenarios in which we can help autonomous vehicles or help in general vehicles in the way. And this results in such things such as merging information. So we'll be able to give you, that detailed, high-rich track data of a merging lane. So for instance, if we take an autonomous vehicle trying to merge into that merging lane, they're able to give that detailed information so that they can make a decision based on, for instance, traffic density or speed of the traffic in that merging lane. And they can make a nice action of merging into that lane. and also accidents up ahead and wildlife over the horizon. So again, providing that over the horizon kind of view that shows something has happened on this highway or motorway over the horizon. So the autonomous vehicle can, be given advanced warning of that incident. If I play this video, this is again from our Navtech radar user interface. So this is a very specific scenario of this that shows actually wildlife over the horizon. So I've modeled a moose happily walking along this virtual carriageway we've drawn here, with the radar in the corner here detecting that virtual carriageway. So the moose is happily walking around and decides to stop in one of the lanes, and the smart infrastructure or the sensor is able to give an advanced warning that, hey, there is an obstruction. In this instance, there's a moose on the road. So for a autonomous vehicle, or for any vehicle for that matter, approaching that incident, instead of having to rely on the local or onboard sensors on the vehicle to make a drastic change to either suddenly brake, swerve into another lane, whatever that may be, they're able to give advanced warning to the autonomous vehicle that there is an obstruction in the way, X meters or X kilometers in the way, just letting you know you can come to a nice relaxed stop, or whatever decision that may be. This is the advanced warning that we're giving you. So I think it's extremely comforting for the road user in that case that this advanced warning system can be capable of that, and instead of having to rely on those localized sensors. And lastly, there's also the added benefit of these dynamic routing opportunities for autonomous vehicles. So if you have a sensor that has this rich high data capability of giving us track data information, you're also able to give that an opportunity for the autonomous vehicle to make a real-time dynamic routing option. So for instance, in this case here, actually, this is again the Navtech radar system software. We've modeled a road next to the ICC in Amsterdam, which was what Intertraffic was supposed to be held this year, but not because of obvious reasons. Yeah, you can see hopefully that we're monitoring a road along or adjacent to that, the ICC, and this kind of track data can be then directly fed into an autonomous vehicle in some way, shape, or form. And then an autonomous vehicle or a vehicle for that matter approaching that road can then make a dynamic routing change if they so want to, if they deem that this is going to take too long to go through that route, and we think there's a more efficient way to do that.
That's terrific stuff. I'm now going to put my head into the space of the local authority viewers of this particular webinar, because I think they're probably looking at this going, this is great, we really like this idea, but are they well prepared for connectivity? And what would you advise road authorities to do in order to prepare themselves for future autonomy? So it's kind of in two parts, the question about how they are with connectivity and what do they need to do to prepare for autonomy in the future.
Yeah, so I guess the short answer to answer your question is, currently we're not as well prepared as we think we should be. And yeah, we really should be as prepared as possible for this. There's obviously a very long way to go before we reach this level of automation. And currently, though, it is becoming more widely accepted that we do need to address some of these concerns I've raised in terms of perception and in terms of something else that can critically ground truth, the data that we're getting from the localized onboard vehicle sensors. And in the case of smart infrastructure, these projects, they do take a long time to get implemented. And therefore, we're saying that it's extremely important that we have these discussions now and really raise awareness and to get things going. And it's just great to have these discussions now to understand the scope moving forward and how we implement it. And in terms of your second question of how would we advise road authorities in order to prepare themselves for future autonomy? Yeah, we would advise the road authorities to understand the need and the implementation for the requirement of this comprehensive road information to the autonomous vehicle from the smart infrastructure. So that a driver now, or maybe an AV or autonomous vehicle in the future, has access to that rich data set, or that rich information. And yeah, basically, again, it's addressing the issues and safety concerns present and discussing the feasibility of how these sensors can benefit us as we strive towards that concept or that idea of full autonomy. In terms of next steps, obviously, this could be to have a proof of concepts on a smaller scale. So looking at it on a smaller scale and understanding the proof of concept, as I just said, and looking at pilot schemes, etc., and really understanding on a smaller scale how this could work before we before we go bigger or think about how it could work on a bigger scale. And yeah, this is currently like what is happening with us actually for Navtech Radar, I mean, and although at a slow pace for us around Europe. We are involved in a few pilot projects of this nature. So it's really good that this is happening at the moment. And I think it's just good that we're able to discuss and plan ahead of how we can do more of these things.
Sean, we've got about 3 minutes left on your slot before, unfortunately, we have to move on. A reminder that you can ask questions in the chat function at the bottom of your screen on Zoom. One question that's come in that needs a bit of explanation to some, which is there's use of cameras, radar and LiDAR, both in infrastructure and on the vehicle. Can you elaborate on this and the strengths of each?
Yeah, sure. So I'll keep this quick then. Each sensors obviously have its benefits and drawbacks, and there is a very strong belief that no one sensor can do everything we need it to. This is why on board a vehicle, we have many sensors working in conjunction with each other. So we've got cameras, LiDAR, ultrasonic sensors, radar, and to speak in broad terms, cameras that have a very good resolution. LiDAR has very good range information. Radar has that all-weather benefit, but perhaps not as good resolution as the others. But in conjunctions, like all these sensors have a place for it in terms of smart infrastructure and on board the vehicle. And we really do think that working in conjunction is going to be truly beneficial for that matter. And I guess from a non-biased point of view, radar has the benefits in the smart infrastructure is what we see and what we believe in as well, because of that long range, all weather and 360-degree views and the ability to get that rich data set out.
And interoperability as well. If you've got different technology on the roadside, different technology in the car, you want them all to be able to talk to each other, but you don't want them all to be able to talk to each other on one proprietary system that you're then stuck with and paying for forever.
Yeah, so system interoperability is a big talking point, and it's good to have these discussions now. I think we need a standardized output format in which we can take this information from the multiple types of sensor manufacturers and manage that flow into this common operational framework that we might have. And this obviously comes with a very good understanding about the type of data that's coming from each of these sensors and then managing that workflow really. At the moment, we do have a few projects that, we do work with some system interoperability where it's managed on a higher level. And this is from the automatic incident detection side. And they make decisions based on the data feed that we send them, which is really interesting. But obviously, when you're talking in the context of autonomous vehicle and vehicles on the road, when we want to send that information to them, this is a whole different ball game because of how rich these data sets are. Already, the processing on the autonomous vehicles is quite rich itself. So it's, again, we need to really think about the framework in mind and the standardized output when we talk about these kind of things.
Okay, right. Very, very quick answers to questions now, as quick as you can. First of all, how many radar do you need per kilometer?
Okay, that might not be a simple question. It depends what you're trying to do. If you're looking at tracking, maybe two or three. But as you can imagine, as the size of the object that you're trying to track goes smaller, you need to put radars in closer together.
Okay. Can you also control traffic lights with radar?
Yeah, you can send outputs in order to do that. So you can say that if your radar is monitoring a road, and you can say that, okay, that's this much traffic on the road or queuing is occurring on this road, you can send that information to a sort of management center. So much like the system operability question you've asked before, and then that management center or that management system can then make that decision based on the input we give it.
Okay, and I've got one last question, and I apologise to those who haven't had a chance to have their questions answered. But what Cheyenne can do is pick up on this afterwards, and the other questions. And maybe Cheyenne, you could answer this on your LinkedIn page or something for people to see the answers, and then they'll all flock to your LinkedIn page and find out more about it. But Harold Kuhn has asked, what are the advantages over floating car data, and how can the technologies cooperate with each other?
Um, I'm not entirely sure about, I don't know how to speak about floating car data as such. Yeah, I think the advantage is that it's detecting the live traffic. So it's giving you, the real information of the live traffic that's flowing on the carriageway. And again, to be able to work in conjunction together, we need to understand that the data, well, where the data is coming from both ends, and the advantages and disadvantages of such. And if we want to try and integrate the data sets, or if we want to try and make a fusion model, it's really understanding, really getting to a technical and quantitative level of understanding that both data sets and the confidence intervals we want to give to each one, if they're sharing certain information that they're sending, or if they're really trying to be combined data set.
Okay, right, Cheyenne, thank you very much indeed. Cheyenne Afshar is from Navtech Radar. Do not go away, Cheyenne. You can go and hide away by switching your camera off in the background, but we'll bring you back for a quick discussion, more questions, and a wrap up at the end of the webinar in about an hour's time. But for now, Cheyenne, thank you very much indeed. We'll move on to our next guest in a moment after we've had our next poll question. So we'll move on to that right now, which is, when will automated driving be feasible without connecting to smart infrastructure? When will automated driving be feasible without connecting to smart infrastructure? You can see the suggestion now, maybe now, but not on public roads, not for 10 years, not for 20 years, or even never. So I'd like to see what your opinions are on timescales to do with the technology that we're talking about here. And we'll wait a second or two while all the votes are counted on Zoom before we move on. And then a reminder that do please send your questions in while our guests are chatting to me, and we'll pick up your best questions, or the questions we've got time for, in each of the discussions before we move on, and any other questions we will have for you offline afterwards. So we just wait for Zoom to pull together the answers to the third poll, which should be any second now. And there you go. Most people think it's not going to be for 10 years, and very, very few people expect it in the here and now, or at all, and then so we're looking at 10 years, maybe 20 years, and a fifth of people watching this webinar at the moment think the answer is never. We will always be dependent on smart infrastructure. So let's now move on to talk more about European CITS and the deployments that are underway, because when it comes to improving safety and efficiency of road transport, CITS services are definitely to be regarded as a key enabling technology. Several stakeholders in the policy and industry sector have empowered the ventures made so far with CITS services, and the European Commission, together with member states and others, have been working on a number of CITS projects. So let's elaborate on the status of European CITS deployment with Martin Boom, who is Head of Business Unit Digital Infrastructure and Data at Austria Tech. Good afternoon to you, Martin. Thank you for joining me on this discussion. So I think you've got some slides as well that we're going to call up on screen in a moment. We'll share in those slides for you. But I'm looking at how many CITS projects there are throughout Europe. How come there are so many, and how on earth, with all those different projects, can you possibly share results and lessons learned and get a clear picture amongst everyone?
Yeah, thank you very much for the nice introduction. Good afternoon. Yes, a CITS deployment. That's more or less, the topic of what we are discussing here. And we know that CITS has a long history already in Europe. We started already in the late 90s of the last century discussing connectivity. And 15 years ago, we had the first integrated projects, CVS, SafeSpot, Coopers, and so on. And then 7, 8 years ago, we really started the first deployments all across Europe. We had a nice, or there is a nice corridor, the CITS corridor, going from the Netherlands through Germany down to Austria. In France, they had some deployments with Scoop and Scoop at F. We have Nordic Way. So there had been several first initial CITS deployments all across Europe. And what we then did, okay, what we have done at the CITS corridor in Austria, we went with our car to France, expected to get a service, and we got nothing. Of course not, because we have very isolated installations. We were speaking the same language, we were discussing the same services, but at the end, we had no interoperability. And that was exactly the point where, from the infrastructure side, from the road operator side, there was a decision: we need to take action. We need to harmonize our services. We don't need to harmonize the systems because the systems are installed, but we needed to harmonize our services. And that was exactly the starting point of the C-ROADS platform. It's very important to understand that C-ROADS itself, it's not a project. It's a sum, as you said, Paul, it's a sum of projects contributing to this European C-ROADS platform, where we are where we're doing a harmonized deployment of CITS services, ensuring interoperability. Can I have the next slide, please? Here you see Europe, and we see that 4 years ago, we started with 8 member states. Very important already at that time, we had Scoop at F, the French projects, and we had the corridor. The CITS corridor. Then we enlarged it also with Nordic Way, with Italy, with other countries. And 2 years ago, in 2018, we had a further enlargement. And you see that almost all European member states are committed towards harmonized deployment of CITS services, interoperable services, ensuring that the car which is going in Austria will also receive its services if it's going to Germany, if it's going to Spain, to Greece, or to Finland. But of course, what we are doing here in Europe, what we also see is it's of interest also for other countries. And we have also associated members. If I can have the next slide, please. Then thank you. Now, the previous one, thank you. Then you can see that what we are doing, because the key element of harmonization is not missing standards. It's in main times, it's a lack of interpretation, commonly interpretation of a standard. You're using the same standard, but you're still not interoperable. So what our major effort is really making out of all the different standards that are existing, commonly agreed specifications. And these specifications are as well seen by these associated members. And we see, for example, in Australia, that they are deploying also CITS services based on the European specifications, which we are using here in our C-ROADS platform.
Okay, that makes a lot of sense.
If we go on the next slide, you also can see what is the aim. The aim is really linking all CITS deployments. I already said that the platform itself is not running any project, but we have several projects which are the already mentioned projects. There are C-ROADS projects, there are Nordic Way projects. We also have Intercore, which might be known here. We also have projects now like C Streets in Portugal or Indit in France, which just recently started. All those are aiming at deployments, but the deployments are done based on published and common technical specifications. So of course, the specifications are done on a platform level. We are also doing and performing cross tests, ensuring that interoperability is not only a wish and a nice word, but it's really existing. And we are using on the technology side, what is there? We call it a hybrid communication mix. We all know that the whole discussions on a global scale, what technology is the best? It's the wrong discussion. We need to discuss about the services. Whoever is the carrier of a service, I personally, I don't care. It's important to bring the service to the road user, because at the end, we want to make our roads safer. We want to warn our drivers. We want to reduce accidents. So the technology is just the carrier. On the right side, you see how the C-Roads platform works. You have in the middle this C-Roads steering committee. The C-Roads steering committee itself, that is composed of member states. So we have the members, the state authorities composing the steering committee. These authorities are acknowledging, they are accepting specifications and ensure that the specifications which are worked in the different working groups, which you see on the left side, that these specifications are used in their pilots, in their deployments. So we have a kind of cycle process using the specifications in the pilots. Out of the pilots, we learn where do we need to improve, where do we need to adapt. We bring this additional knowledge to our working groups. They improve the specifications, which are again acknowledged by the steering committee. And so we have a cycle proof concept implemented in this C-Roads platform. I already spoke a lot about the services. What is meant by services? What are we aiming for? And looking to road authorities, we have three major aims as road operators. The first aim is safety. Currently, we ensure that we have a safe road infrastructure. Of course, we also look towards efficiency, and very important, especially now in Europe, is also an environmental impact. We need also to look on the environmental impacts. But the first driver, especially for CITS, it's safety. And you see here a communication from the European Commission, which was published in the same year where C-Roads was funded, that was in 2016, where they have already in their CITS strategy defined the day one CITS services. And you see here, it includes roadworks warnings, weather conditions, emergency vehicle approaching, but also all the speed limitations. We also have the traffic light information and so on. This whole day one service list, their specifications are existing and used. They are currently in the deployment phase. But we are also thinking already to the next generation. What is afterwards? And here we see in the same communication from the European Commission already a first list of CITS day 1.5 services. But those will not one by one be implemented, because we identified that, especially looking to urban areas, that there are slightly different needs. You will not find here the interaction with public transport, for example, which is very important. Coming a tram from the left or from the right, at least in Austria, it has priority. The information, the interaction between public transport vehicles and individual cars, it's a very important issue. And also here we are, for example, also working on specifications. Other example for day 1.5, where we also have already our specifications ready, is on-level railway crossings. We see in several countries that we have severe problems at railway crossings, that we have terrible crashes between trains and individual cars. And warning here the individual car about an approaching train, it has a huge added value for the whole society, for the infrastructure. And if we can go to the next slide, and then you will see again all these services. Please, next one. And you see that there is not only one specification which is fulfilling a complete service, but there might be services like other hazardous location notifications, which is not just one specification. In this case, we have 8 different specifications, which are public available via the C-Roads platform and also our website, and which are also used for the implementation.
Can I interrupt there a second, please, Martin? Because I want to understand, you've shown some of the services that are involved, but Cheyenne was talking about radar sensor technology, but what technologies are part of the CITS pilots?
Yeah, as already stated beforehand, we are not so much looking on technology itself, we are looking on services. But of course, we need to use technology to transport our services. And can I have the next slide, please? Then you will see, yeah, that we are using both. We are using short range technology as well as long range. Speaking in easy words, short range, it's like Wi-Fi, and long range is cellular networks. It's telecom networks. We also expect that we will need both. We will need both. It's not the one or other. It's always an and. We need both because a short-range communications technology can be very important if you have bottlenecks, if you have really a critical infrastructure where you need to inform immediately. But looking to the Alps, for example, to the mountainous areas, to the very rural areas, nobody can expect that short-range communications technology is introduced everywhere, all around the country or all around the globe. So we need to have a combination of both. And if we are using the combination of both, it is also important that the messages that go through are one by one the same message with the same identifier. Because if you're then traveling in a rural area and you have there, for example, in a small city, a hotspot, and receiving a different message via short range than via long range, then you have a problem, especially an automated vehicle. You will see here also that we are currently focusing on 3G and 4G if we are looking to long range, because 5G here we are still in a learning stage, but we started already deployments now. I will come to that later. So if I start today with deployments, I need to use what is existing today. I can transfer it. I will use in future, of course, also 5G. And looking to short range, you will see here the 11P, the Wi-Fi technology, which is the choice for today. And that has also a very easy reason. Yeah, I know all the discussions about CV2X, about LTE-V2X and all those things, but still also there we are still in a testing phase. And this is a very important point, we have no backwards compatibility today. That means if I develop 11P further, still my infrastructure I deploy today will work also in 3 years, 5 years, 7 years, 10 years time. I'm not so sure at the moment with the other technologies. And you must remember, if an infrastructure operator deploys technology, usually the technology change is not that quick than we are changing our mobile phones. Usually an infrastructure decision for deployment is taken for a 10 years duration at least. That means whatever is deployed should be stable, work and running for at least 10 years. And going back to my mobile phone, I had 10 years ago, of course, as well, a mobile phone, which might not work today in the cellular networks, but the Wi-Fi connection still would work because that's a backwards compatible system. That's a decision today, which does not say anything about the future. It might be, and I'm quite sure that in future, other technologies will come as well. And one thing is as well worth to say, a road operator has always the plan to serve all his users. Meaning if some OEMs, some industries deciding to have a large scale deployment with another technology, I'm quite sure that the road operators will follow that approach to serve all road users. For the current stage, it's 11P. Continuing with the technology, can I have the next slide, please? We also see that security is very important. Also here, we are working very much and very deeply together with the European Commission to have aside the service itself, also a certificate, a security certificate that this message we transmit can be seen as a true and valid message. Because especially when it comes to automation, we know about several attacks, we know about terrorism. It might be that there are wrong messages around, which just tells your automated car to turn left, to turn right, even there is a wall or a wrong way. So therefore, security is also very important, which is also a core element which is implemented by our services.
Martin, I'm going to butt in very, very quickly and just warn you, you've got the 2-minute warning now on your discussion. And then I do have a couple of questions coming in from the audience. So I'll just hurry you along a bit, please.
Yeah, I just will go for one slide because that might be the most interesting one for most of you. Where do we stand with our deployments? Can I have the next slide, please? Yeah, here you see all the green dots. The green dots are CITS stations on short range, which are currently up and running in Europe. You will now say it's a strange number, but it's in fact, we have 999 stations up and running. More are coming in the next quarter. And if I can have the next slide, then you see I just choose one location, which is a city of Brno in Czech Republic. They are not only on motorways. We already started to include also urban areas. And especially in Brno, you will see that, for example, all trams are equipped with CITS. The fire brigade is equipped with CITS. And they already see for their internal processes a huge benefit in using CITS. The fire brigade saves up to 2 minutes from to approach to an incident. 2 minutes if a house is burning, that's already some time.
Excellent stuff. Have you got 30 seconds to just give us an outlook on the future for us, please, Martin?
Okay, yeah. The future, of course, we are doing continuous procurement. We are involving new member states. We are looking to city authorities. We have already a commitment of several of those. We are focusing on urban CITS. And most importantly, cooperation, cooperation, cooperation. We need to cooperate with the OEMs, which is in our case, most importantly, the Car-to-Car Communications Consortium. And we need to work together really afterwards on maintaining the systems. to include also new releases, to work on new releases, to have this system not just installed, but also maintained and up and running. But currently the focus is still on the deployment.
Okay, one question I've got time for, because it just picks up on what you just said there. Explain a little bit more about how C-Roads is involved with V2V services, because you kind of mentioned the car-to-car, and Mark W has asked the question saying, is C-Roads just infrastructure-based services?
C-Roads is focusing really on the infrastructure. But of course, we have a very close relation with car-to-car. We have weekly meetings with car-to-car. That means that the car-to-car communication consortium is really harmonizing what's happening on the vehicle side, and we are harmonizing what's done in the infrastructure side, and we are going hand in hand really in our deployments.
You're a good man, Martin. Thank you very much indeed for your time. We could have probably filled 90 minutes just with you talking through all of that, but unfortunately we're out of time. Don't go away. We'll come back for the wrap up at the end, but let's move on now to our final poll question before we then meet our final guests today. What is the most essential in realizing nationwide CITS? You've got the choice of cooperation amongst different public and private stakeholders, setting up field operation tests, the possibility to test new technologies, creating open data platforms which are able to connect with various roadside systems, aligning with international standards, or all of the above. So, you know, are they all essential, or which one would you choose if you had to plump for one of them? That's our final question. I'll give you a second to make your decisions on that one. And then we will move on to our third and final guest of this Intertraffic webinar. Let's see, the answers have popped up, and half of you have plumped for all of the above, the safe and simple answer. Interestingly, only 6% have said setting up operational tests, and it's quite close between cooperation amongst different public and private stakeholders and creating open data platforms which are able to connect with various roadside systems. And I guess that those that chose those ones would say that aligning with international standards is a given on that one. So that was your final answer. It'll be interesting to see what our final guest thinks of that. We're going to look at lessons learned from large-scale CITS data exchange in the Netherlands and European projects. Let me just introduce very quickly: with rapid growing exchange of mobility data and services within Europe, we should ensure that users can count on up-to-date information and driving advice across national borders. So the TLEX platform is using several large-scale implementations, a central CITS data exchange hub. It's used as a building block in various national and international CITS implementations, such as Talking Traffic, Intercore, and Concordia. So with CITS, where do we stand and what have we learned so far? Let's find out from Paul Potters, who is Director of Smart Mobility at Monarch, who you will see has joined us now. Paul, thank you very much. Talked about national rollouts. What do you think is most essential in realizing nationwide CITS?
Thank you, Paul. I would like to share with you some slides on our lessons learned in the Netherlands. Next slide, please. It all started in 2015 when we had decided to have all traffic light controllers to exchange their data with the road users in a two-way way. We call it the Talking Traffic Partnership, and it was the start of the Dutch national CITS ecosystem, which is now fully operational. And everybody will understand this case has a lot of technical challenges. Today, over 1 billion messages per day, and with a maximum latency well below 50 milliseconds, are in the system. The tech people had a lot of work to do, but next slide, please. There were bigger challenges, such as aligning all the different authorities, the road authorities, which we have a lot in the Netherlands. Each city has their own road authority, together in this partnership, but also companies who are used to compete each other. They have to set aside part of their own interest for the greater good, and also aligning the authorities with these market parties was really a challenge. And next slide, please. Honestly, no way we could have done this without the support of the national government. They created the circumstances that were essential and now offer the opportunities to give priority or information to all the road users in the Netherlands. So what were the lessons learned while doing so? Next slide, please. Essential is that there is a robust ecosystem. Essential is there is a robust ecosystem with the strategic and operational cooperation between all those parties, as I said. It was a time-consuming process with a lot of meetings, but really necessary to comply to all what our previous speaker said, all the interpretations of all the things we had to do. A lot of working groups were working on specific tasks to do that, and support was really also the key in making that happening. The documentation was available to all at every time on a national platform. We had a central ticket system for the management of all kinds of issues, and the real-time monitoring of the operation was really key in support to see if everything works according to all the technical standards. Next slide, please. Security and privacy, as mentioned by Martin Boehm. We are PKI ready, aligned to the European standards. The contracts between the controllers and the processors of the data took us in a legal sense also a lot of problems, but it's now all there. And we adopted the ISO 27000 scheme in the information chain to secure that everyone has the same level of security and privacy by design. To wrap up, nationwide coordination is really needed because there are also things like the topology of the intersections. We have the standards and the profiles in the public domain to be managed, and small things like a unique ID of every intersection of every roadside unit in a system. So now we have a fully operational system. All @C messages are there, and a number of intersections and roadside units are available to the general public.
That's good stuff. Thank you very much. Now, explain to me, sorry, I'm just switching my video back on so you can see me in all my glory. Explain to me about the traffic talk that you've been producing, the sort of the purpose of it and the background of what Monarch have been doing in what you call traffic talk, please, Paul.
Well, next slide, please. Monarch is all about connecting data, transactions, and services to achieve smart, safe, and sustainable mobility. Next slide, please. And to do this, we developed the TLEX platform, which is a highly scalable platform, especially designed to connect roadside equipment to information brokers, the automotive industry, road authorities, and ultimately the road users. All of this bi-directional, continuously, real-time, and vendor independent. And this platform has now been procured for the next 4 to 8 years as the national CITS data exchange platform in the Netherlands, which makes it possible, like our first speaker said, to have all kinds of sensors and all kinds of road tuners, traffic management systems, authorities, analytics parties, and ultimately the road users connected in one data cloud to have fully profited of all the services available. And our clients to do this was all made possible by the road authorities on a national level, on city level, and on regional level. And they are unable to achieve their policy goals by the data exchange platform. But we also see now that logistic hotspots like ports, etc., who have a need for sharing data in an organized way and have a multi-stakeholder environment can fully benefit for the TLEX because there's also a lot of management and governance available, and every user has its own platform which he can be in fully control of what happens with all the data issues.
Okay, so you've explained kind of the Telex hub, how it works and where it's used, and you said clients are what? Road authorities, technology vendors, service providers, road users, etc. Mention a few road cases. I'm just thinking of one specific example. So let's say smart traffic light controllers and services, which I know are installed in many Dutch cities. Can you mention a few use cases in the Netherlands and indicate
Yes.
what they can contribute in terms of policy objectives?
Next slide, please. It all consists of three levels. First, we have the information. Information is time to green, which can be used for a recommended speed to have a green wave in a city, but also in-vehicle signage and speed advice, as the day 1 and the 1.5 services all about, roadwork warnings, hazardous situation. And on a second level, it's also able to optimize the planning based on incoming traffic and to add policy objective as reducing congestion, emission, or improving traffic flow and safety on the level of the intersection planning. So it's not only informing the public, but also informing the intersection about what's in the vehicles are approaching, and then change their planning. And prioritization is always also a very main use case. We see priority requests from designated traffic like ambulances or truck platoons to have 7 to 10% improvement of the mean travel times. We have a very nice report by B-Mobile recently published on what is all achieved in the Dutch talking traffic environment. And this also is to do with road safety, because safe passage on intersection by emergency services is very important. And it was very well received, and the police, the ambulances, the truck platoons, they all see a great profit also for the road user and not only for the road authority safety.
Terrific stuff. Just looking at excuse me, at that slide, the priority, you know, it's a really important thing to get priority for public transport vehicles, and especially emergency services. And of course, from an environmental point of view, being able to keep heavier vehicles from stopping and starting vastly reduces their emission. Yep. You've got there, you talk about the GLOSA and network optimization. Explain a little bit more about that for me, please.
Well, GLOSA is all about having a speed advice in the car, on your dashboard or in your app, to have the best throughput through a number of intersections in or out a city. To do that, we are still learning what are the best ways to achieve it, because it's an like we say, talking traffic. Road users are talking to the intersections and back, using the ETSI messages, CAM, MAT, SPAM, SPET, and MAP messages to make the best out of it. But essential is a good mechanism to verificate and that only the good data is in there, with continuously checking of the compliance of the data model, and maybe the most important of all, the certainty, and with the maximum security, privacy, and governance. Because what you don't want to happen is that someone can emulate as is if he were an ambulance or something like that. So to summarize, it's very important that there is an exchange, and the data is not only in a technical way able to be interacted, but also for accountability for correctness and the quality of the data.
Now, I've seen as a journalist, and actually for many, many years, running operations at two separate traffic news companies, that this kind of data exchange is very important. And I've seen it on a small scale. I'm not sure I've ever seen anything quite on such a large scale as this. What lessons have you learned? Give us some striking insights, Paul, as to what you've discovered in being involved in this.
Well, currently in the Netherlands, the urban data access platform has been procured, and for the next 4 to 8 years is operational. It's a proactive support for all stakeholders and the contribution to not only technical standardization and stuff, but really to have a finger on the pulse to see if all the data streams are being available for everyone on a high quality and can be managed by the road authority or other owners of those data. So if a service is operational, to have a very large implementation, and in our case on a national platform nationwide with all roadside units, we have experienced that the cooperation and the way you cooperate is essential to make it happen and keep it on a very high level of quality available for all users in the system. So until now, I would say don't focus too much on technologies, same as Martin said, but on the way forward to implement it and to work together in an ecosystem with a central platform which can manage those large amounts of data in a quality high way.
Okay, you mentioned Martin there, so this is actually, I was thinking about this is fascinating what you've done on a Dutch level. How have you pushed that into knowledge sharing amongst the other projects across Europe?
Well, we are active in other countries throughout Europe, of course, in the Nordic way. Belgium is procuring the Mobili data system, which we're very anxious to see how that and quick that will be adopted by all players in the market. So for proof of concepts on other CITS regions or whatever, we are able to make it available for others in a very short time because it's already there, and starting throughout Europe together with partners to bring our solutions to the market.
So the actual data hub, the data exchange hub that you have, that can automatically be used in other countries, or do they have to kind of take what you've learned, cookie cutter it and do it themselves?
No, it's available on a short notice for all people because it uses the C-road standardization, like all the ETSI, the SPAT, the map messages needed as agreed upon on a European level. So the implementation is there. We have proven in the Netherlands with over 800 intersections already operational, and a lot of roadside units also attached to it, that it works, and it also works in the complete chain until the road users, being cyclists, being ambulances, being normal road users. So it's there, and I invite all others to reach out to us and see how quick we can start implementing this.
Okay, I've been scribbling some notes down as you've been talking here, Paul. One thing I noticed when I was preparing for our conversation, you're currently working on a new urban data access platform, which is a follow-up to Telex. What's the difference between them?
Well, the Telex software is used as the core of those kind of things, but to have a smart city or a nationwide platform, it's all about support, the proactive support to all stakeholders. That can be different. So on a national level, you have to have unique numbers for your intersection or whatever that can change in another country, another region. But like I said, it's if you have a multi-stakeholder environment and you have to have real good governance on what data is used in what environment, this platform can be very beneficial for you.
Okay, fair enough. I'm going to put you on the spot as well now, because we're thinking of Intertraffic next March at the RAI, when I can't wait to see people in 3 dimensions. I'm looking forward to having feet that hurt at the end of the day because I've walked around so much, which you always get at Intertraffic. I'm looking forward to the to the conversations there. On the roads around the RAI in Amsterdam, what of this technology you've been talking about actually exists, and can we see it? Can we feel it? How do we benefit from it when we're actually all together in Amsterdam?
Yeah, we would very much like to give you the full song and dance what can be achieved with this system. It's very open, all the information. You can see maps on the internet of all intersection and roadside units which are attached to the system. And now it's every new intersection or section that has their hardware being replaced is automatically added to the system. So it's a matter of time that the complete, all the cities in the Netherlands have their intersection on this system. But we also like to have all the roadside units, like temporary things, accident warnings, the end of the traffic jam warnings. Everything is now available to be added to this ETSI stream and directly to the same service providers, which are already taking advantage of all the information available.
Right. Okay. Thank you for that. Let's move on to some of the questions that have come in on chat for you. I'm not sure if you can see these at the same time, Paul, and whether or not you've had pre-warning of these questions or whether these are going to be a surprise for you. But are the ITS 5G RSUs also implemented in the traffic signal systems for traffic management? Asks Mohammed.
The discussion about short range and long range is the same answer as Martin said. In highly dense populations area, there will be short range available, but the same services on nationwide for everyone, you need also the data cloud as we provide. So just add TLEX and you have also everyone from the long range available. And on the other hand, it's also a matter of money, about investments of roadside authorities, what they are able to invest in hardware or smart combination of existing services. So I really don't think it's a technical discussion. It's a discussion of can we keep the services on a certain level available for the road users.
Okay. What percentage of vehicles, asks Ulrich Janssen, are already actually ready for the presented platform?
We're talking about connected cars. So every car that is able to send and receive ETSI messages is now in the system. But also we have a lot of app builders. In the Netherlands, we have a number of apps available. We see millions of CAM messages coming from Flitsmeister, Truckmeister, other underway, the Dutch translation of apps, and they can use it just to inform the public, time to red, time to green, or also to be completely part of the system and sending their positions to the intersections to see if it can be better managed.
Okay. Samuel Salini asks, since the communication is bi-directional, who's responsible for the data and who owns it?
Well, the owner of the data is the party who sends it. And in our panel, you can manage your own data and see what happens with it. Normally, each intersection is managed by the municipality. They have their own way of logging into the system and see if it works properly and add new roadside units. And on the other hand, the road users, well, it's about service providers or the automotive industry to see if their data can be shared in what kind of legal way.
Okay, and I've got time for one more, I think. How does the TLEX platform, how is it related to the National Data Warehouse?
Well, the National Data Warehouse in the Netherlands is in the procurement of our system leading, and they are more or less the combination of all road authorities working with us to have this system up and running in a proper way. So we are the tech specialists from the industry who make it happen, but the UDAP, as we call it, is procured by the combination of all road authorities in the Netherlands.
Excellent stuff. Thank you very much, Paul. Let's call back now Cheyenne and Martin, if they can switch their cameras back on, because I think, gentlemen, what I'd be interested in is your views on each other's presentations. Cheyenne, what have you picked up from Martin and Paul that's particularly excited and interested you?
Yeah, I think it's both presentations were really good and really highlighted the impact of the CITS nature of the CITS world and the impact of having a robust system in order to be able to communicate on many different levels. So I think that was particularly interesting, and the fact that they highlighted both of them, they highlighted, yeah, the importance of that is yeah, is very good and interesting, and it's something that
For me,
think
it was
lots of
very
technology.
interesting, Cheyenne, to see that your radar system has all kind of information, like crossing there on the other side of the hill, etc., which only can be sent to the road users by using a cloud platform or something. So it would really be interesting to have all the radar data also available for the general public.
Yes.
Sorry, carry on, Martin.
Yeah, what I have learned and what we have seen today is that the infrastructure is well prepared. We have good sensors and we are still improving our sensor networks. With our central systems, we can manage our data. We are preparing the services. We can really support all kinds of connected and automated vehicles in future. It's not that the road authorities are not prepared for the future. And for me, that's the very most important story we have to tell. Infrastructure operators, we are prepared for the future of mobility. And we are a part of that. And coming back to the last question, or it was the question before, we asked, do we need to have connectivity for automated vehicles? I'm quite sure we need to have connectivity. Look at the radar sensors. How to identify a deer behind the hill? Will that be the autonomous car, or will it be an automated vehicle, which is a part of the whole automated ecosystem? And here, road operators have also a very important part to play, and I'm quite sure about that. And we have seen we are prepared.
I want to pick up on that then. So what role do you see? How do you see the role of road operators in testing this new technology? And actually, they're not just testing it, because we can test things and do pilot projects till the cows come home, but actually deploying CITS.
I think the core element is really cooperation, because through cooperation, we come to trust. Usually in all our ecosystems, we don't trust the other. But CITS, the C stands for cooperative ITS, it already says we need to cooperate, we need to trust each other. And that's something what we need to learn. We know that one authority does not 100% trust the other authority, and it is the same then with the industry. And we are now building an ecosystem which is built on trust. And that's the huge challenge what we are dealing with.
One thing I've always said since I started, especially since I started writing about this, editing magazines and writing news stories as a journalist about this, and when I go to events, it's one of my bugbears that people who've read my random jottings in time will understand, which is we talk about connected and autonomous vehicles as one thing together, but actually the connectivity that we've talked about is here and now and doing great things. And I think what you three have talked about here today is the amazing way that we've got more safe roads and more informed drivers thanks to connectivity. Can't we divorce the two and say that autonomous vehicles, automated technology, driverless cars will come along the line? Connectivity is vital to that, but actually connectivity is so much more and can deliver so much in the here and now.
The connectivity can bring now a lot of safety on the roads without a lot of investment or complex technical things, because warnings are there for still standing vehicles. All kinds of hazardous situations can be put into the vehicle very quickly without having a completely autonomous vehicle there for you.
Yeah, and having the best of all senses as well is really good. So it adds to that trust, as you said, and the safety as well. So getting the best input from everything is just really important, I think.
What you just summarized, it's exactly the story of C-Roads. We need to act now. We are prepared. That is the decision in Europe. Yes, we are deploying CITS to warn first of all, the drivers to interact with the driver, and in future with automated functions within the vehicle. But that's a future. Still warning a driver, it's a learning phase, because trust is not something what just happens. Trust is something what we need to learn.
Okay, I'm going to go ask one last question, then we'll wrap up this fascinating discussion that I've really enjoyed and learned a lot from. So thank you, gentlemen. But Martin mentioned driving, suddenly going into France and everything going black. What is the most essential thing in your advice to our audience that's all across Europe and beyond? We've even got at least one viewer in Nepal, which shows how popular Intertraffic as a brand and the Intertraffic webinars are. What is the most essential thing in your view in realizing the transnational operability from all that you've learned?
The willingness to work together. Usually everybody is looking at his technology in his country, the support, of course, the own country, and then we run with isolated systems. This goes not only with states, this goes with cities, this goes with single authorities. We need to trust, again, trust. We need to trust the others, and we need to be open to work together. And at the end, everybody will have a piece of the whole system. It's not one will serve all. Everybody is part of it, and everybody will also fulfill his role to make the roads today safer, not just tomorrow and the day after tomorrow, but already today.
Yeah, and it's the same thing what happened to paying systems. First, it starts on a national level, but everyone can see the advantages of working together transnational, and you just have to sit together and make it work. It's not rocket science, it's just doing so and trusting each other that it can work as a fully serviced throughout Europe or what have you.
Yeah, and I think understanding the gaps we face in moving forward is extremely important to acknowledge. And I think platforms such as these are really important to get that message across. So
yeah, it's terrific stuff. Is our society ready for it?
Yes. It's an easy answer. It will not change anything in the first step. You will receive all the warnings faster in time. And if I today go by car in Austria, in Vienna, I have my broadcast on, I will get the traffic jams from Western Austria, which is far away. I'm not interested in. I will be focused very much on the messages, which are for me and not for the whole system. I will get personalized messages. That's it. That's the starting point. And then, of course, more and more automated functions will follow. And we see that already today. Look at the Tesla. There are automated functions which people are getting used to. And they are just switching them on, even they are not allowed, and using them. It will be a stepwise approach. It's not from today to tomorrow, everything will be changed.
We're not only ready, it's already reality. And
yeah.
Let's start using it.
Okay, right. Paul Potters from Monarch, Martin Bohm from AustriaTech, and Cheyenne Afshar from Navtech Radar. You have been three fantastic guests in the last 90 minutes on this Intertraffic webinar. Thank you very, very much indeed for your time and sharing your expertise. A question popped in at the very, very end from Laden Baharman, who mentioned using connectivity for information in parking lots, which is very, very interesting because that allows me to seamlessly throw ahead to our next webinar, which will take place on the 27th of October. The next Intertraffic webinar is on parking as an integral part of the seamless travel experience. So I'm sure Loudon Baharman will be at that webinar. I hope you will be too. A recording of this will be available online on the Intertraffic website in due course. And all the questions that we haven't managed to get through in the webinar chat will be shared with our panelists, and they will be able to answer any of those questions, probably on their LinkedIn pages. So keep an eye on there for any answers to any of the questions we didn't get time for today. And I mentioned the next webinar on the 27th of October, and as if by magic, my colleague at Intertraffic, Fleur, has already posted put in the URL for you to sign up for the webinar on the 27th of October. So I look forward to seeing you then. But for now, thank you very much for joining us on this webinar. It's been a fantastic discussion, and thank you for your questions and taking part in the surveys as well. For now, have a good rest of the afternoon, and thank you ever so much for watching.
Thank you, everybody.
Thank you.